Arduino is an open-source electronic platform whose heart is an 8-bit microcontroller Atmel AVR. It was created as a simple prototyping tool for students with no experience in electronics and programming. Because of its simplicity, it gained supporters all over the world, especially in the so-called makers. Due to the growing demand, Arduino began to develop by adding new versions of boards dedicated to various purposes such as Internet of Things, medical measurements, construction of 3D printers, or embedded systems. The Arduino Mega 2560 board has been designed for complex projects and equipped in 54 digital input-outputs, in which 15 of them can be used as pulse width modulation (PWM) outputs and 16 analog inputs. In addition to the much richer number of digital and analog input-outputs, the main advantage of Arduino Mega 2560 over MyDAC is having PWM outputs, I2C and SPI buses. The main programming environment dedicated to Arduino is based on C++. However, there is a Linux library created by LabView Maker Hub, organization that supports the makers community using LabView. Linux library is not installed by default in LabView. However, you can install it using the package manager. After installing Linux library at the beginning, upload the firmware to Arduino by selecting Tools, Maker Hub, Linux Firmware Wizard. In the window, select the board type from Arduino Leonardo, Mega 2560, Nano, Pro Micro, and Uno. Then select the USB serial port to which the Arduino is connected. Let's open an example that allows to switch on and switch off the light emitting diode, LED. The program starts with calling the open serial function, and then in while loop the digital write function is called, which sets the true-false value to the selected pin. After pressing the stop button, or if error occurs, the while loop ends and the close function is called. Let's go to Arduino now. On the proto board, we have a connected LED to the 330 ohm resistor. Now, connect the anode to digital output number 7 and the cathode to the ground. Let's change the pin number on the front panel and let's run the program. We see that the diode is turned on and off when the left value control is pressed. In addition to controlling digital pins, we can use PWM outputs. Let's create a program that will enable us to control the DC motor. To do this, create the while loop and add the stop button. Then open serial connection with our Arduino board using the open serial function. The DC motor speed is controlled by setting different duty cycle of PWM signal. To do this, add the PWM set duty cycle function and create two numeric controls. One to change the field in the 0-1 range and the second one to control the direction motor rotation. To change the direction of rotation of the DC motor, send a value of 0 or 1 to the digital output. Let's add the digital right function and create the direction and dir pin controls. At the end, connect the error clusters and call the close function. Let's get back to Arduino. The DC motor is connected to the DRV8835 motor controller. Connect the controller to Arduino to the PWM output and direction pin to the digital output. Let's run the program. We see that with the PWM we can control the motor speed and we can change the direction of its rotation. Let's now move to analog inputs. Let's create a program that reads the voltage from the LM35 sensor and converts it to temperature value. Let's start by creating a while loop and a stop button. Then open serial connection with our Arduino board using the Open Serial function. In the while loop, add the analog read function and create the LM35 pin number numeric control. Let us now create a voltage indicator to which we will write the red voltage. To convert the voltage to temperature, multiply the value by 100. Let's pass the temperature value to a waveform chart. Finally, let's add the close function. Let's go back to Arduino. Let's connect the LM35 temperature sensor to the analog input. Let's run the program. We can see that the temperature value is displayed on the chart. When you touch the LM35 sensor, the temperature slowly increases. In addition to analog inputs, digital input outputs and PWM outputs, Arduino is equipped with I2C, SPI and serial port peripherals. To demonstrate the way of communication through the bus, we create a program that reads the pressure value from the LPS331 sensor. To do this, create the while loop and the stop button. Then open serial connection with our Arduino board using the open serial function. Then let's use the I2C open function that opens the specific I2C peripheral. In order to establish connection with the humidity sensor, send the value 15 to the I2C bus. To do this, use the I2C write function. If everything went well, the sensor will return the value 187. Read the value from the sensor using the I2C read function and save it to the connect indicator. Then close the specific I2C peripheral using the I2C close function. To read the pressure from the sensor, send the value 168 to the I2C bus. For this purpose, use the I2C open function and the I2C write. The pressure value is transmitted in 3 bytes, so we ask to return just 3 bytes of data from the sensor. Let's use the I2C read function. Let's use previously created sub-VI, which according to the documentation to LPS 331 merges 3 bytes of data and converts them into pressure. Add a waveform chart and on which we display the pressure value. Let's add a delay. Then close the specific I2C transmission using the I2C close function. Finally, let's call the close function. Let's go back to Arduino. Let's connect to Arduino Shield, which has sensors for temperature, pressure, humidity and illuminance. Let's run the program. We see that the pressure is displayed on the chart. To sum up, with LabView you can easily control Arduino, to which we can connect both digital and analog sensors. We can also control DC motors using the PWM output. In addition, there are buses available for which we also have appropriate functions in the links library, which make it easy to read data from the sensors via the bus. In addition, in functions, maker hub, links, sensors, we can find a number of functions that facilitate the use of sensors such as accelerometer or ultrasound distance sensor and a number of other functions, for example servo control.